was recorded on August 24th, 2007, approximately 8:15 p.m. In your typical telephone central office, you'll have a 48-volt power source, which would be a rectifier connected to batteries, which would carry the load during a power failure or also peak demand. So each central office would have a rectifier of 100 amps, 200 amps, 1,000 amps, depending on the type of an office, the size of the office, and so forth. In this particular machine, we got a 100 amp Lorraine rectifier, and it's currently putting out 52 volts. And we're at approximately a 6 amp draw at this time, running the step-by-step switching equipment, the touch-tone converters. So in the idle state, we do have a little bit of a load, but it's not that difficult. Currently we're looking at the power distribution for the central office because I have one single 100 amp rectifier running the entire building. I have that fed through the XY power distribution board with an ammeter and fusing, and then it comes over to the bottom panel here, which then fuses the individual panels, and then each of these leads running goes to a switch frame or a relay rack, depending on what the source, or excuse me, what the load is. I have one miscellaneous relay rack that runs all of my low amp supplies to the trunks and so forth, and then the rest of this would be switch frames, filters, as well as other things, fuse panels, and the A&ID has its own fuse panel and filter. Well, we're starting out with, after the power system, which runs everything in the building, the next probably most important thing would be the central office mainframe. This is where all the cables from the switching equipment tie down, so we can associate a line equipment to a telephone number and then connect it to a cable pair leaving to a customer's home or business. In this particular mainframe, we have 1,000 telephone numbers approximately and lines. Because I'm building a central office with various manufactured equipment, I have everything on one frame, so you could say this is a super combined distributing frame. In this case, we have our line equipment. This is where a subscriber's dial tone comes from. Then up here on the connector shelf, we would run a 3-conductor jumper from a specific number down to a line equipment, and then from the line equipment to the cable pair. The nice thing about this particular office and the step-by-step equipment is you can take any connector terminal and wire it to any line equipment. So the jumpers are really random. They do make sense and so forth, but I can connect anything from anywhere to anywhere. If I wanted to have a multi-party line, then I would have a bunch block on the other side of the frame where I take either 2, 4, or 8 subscriber numbers and tie them to one connecting block, and then it would tie down to a line relay, and then from the line relay to a cable pair going out through the community. Alright, well, everybody starts out on line equipment, which each telephone line has its own individual line and cutoff relay. That line and cutoff relay, when a person goes off hook, you operate the line relay, which then will request the line finder to come in and find the line that is requesting service. Once the line finder has found your line, it connects into what is called a first selector, and the first selector provides your dial tone, and that's where you begin to dial your either 1 for your toll call, 0 for the operator, or the digits required for the local prefix of the community you're in. In this case, I'll go off hook and operate this line finder, and it'll find dial tone in about a second or so. During that time I found the line, I'm going to go off hook and on hook again. This is effectively a mechanical operator in the way it's operating. Instead of a person sitting here waiting for a drop to drop and pull up a cord and plug into it, it's all done mechanically. And this is what's called a Strowger step switch. There's 500 of them in this particular building, and in this case we have one line group which has 200 subscribers and 20 links, so you can have 20 telephone calls originating out of this group at one single individual time. Because it's a lockout line group, which would be for farmer lines in a community where you may have open wire. If the tree went across the pole line and took the cross arms and shorted the wires together, you'd lock up all the equipment. Well, if you have a lockout line group, there's a permanent signal time release that if you don't dial anything in a predetermined time, it locks your line out so that you don't have one pole line taking out an entire 200 line group, busying out all the paths. In this case, the trim line phone I have in my hand is connected to the line and cutoff and lockout circuit I got my finger on, and I'll go on and off hook 2 or 3 times, and you also hear the line finder in the background, which you've seen previously. So as you can tell, I've got my line relay, my cutoff relay, and I have a lockout relay. And in this case, I have touch-tone converters on the office, so if I call myself here at this phone number, it would be busy, of course, because I'm on that line. And the call went clear through the office, took 3 to 5 seconds, depending on the digits dialed and the levels used. Alright, at this point I have the line finders in a test mode. On the 3 line group we got 60 links, so at this point we have through the 3 line groups, each one is running its own test circuit, so it gives you an idea how noisy a large central office would be. And I'll step out of the way and let it run for a minute or so and you can get a handle on it. And also the covers off here. We're now at the first selectors in this particular exchange. All 60 first selectors are in one individual switch frame, starting out with the first selector shelf number 1, number 2, all the way up to number 6. I have cables running to my main distributing frame, my ANI, and so forth, as well as other selectors off of these blocks. Because I don't have a DTA type of an office, all my grading and jumpering is done between the miscellaneous block and the bank block. And so in this office I have level 1s wired to an ANI trunk, level 0 would be wired to an operator trunk, and then level 3 on each shelf is wired to the next selector shelf, all 10 positions, and then this shelf, level 3, is wired to a different selector shelf, all 10 positions. So this way I can get 60 telephone calls simultaneously in the office due to the way it's been wired and constructed. This particular exchange code is 377, and I have 5 additional codes that are what's called Eas Routes to other switching systems in the building. So if you were in a large Bell System central office, you would have first, possibly second, third, and fourth selectors, fifth selectors. In my case, I have first, fourth, fifths. I do have seconds and thirds depending on the number you dial to get to the other exchanges. So again, there is a massive amount of hours of wiring in this particular area right here, I probably have about 300 jumpers or better that's been wired on just this particular shelf alone. From the line finders are wired through a touch-tone converter, and then from the touch-tone converter to the back of the first selector switch. This is where dial tone originates once you go off hook and get a line. In this case, I'm going to dial a 3, and it will cut in on level 3 by 1. If this terminal was busy, the switch would rotate to the next terminal and so forth until it found a vacant path, or it would give you 120 IPM all circuits busy. Because this office code is 377, I'm not doing any digit absorbing on this particular switch at all. And if I dialed 1, I would be going into my A&I system. If I dial a code of 5, for example, that'll put me into another selector shelf to get me on an Eas route to the number 3 crossbar system. And we're looking at switch number 10 on the end of the shelf, and they all do the same function. In fact, all 60 switches are wired to perform the same exact function, so this is for video and the best choice we had. Alright, we dialed to digit 3 in the first selector, and that got me over to what I'm calling my fourth selectors. Because I was on switch 10 over there and there was no other traffic, I would have ended up landing on switch number 1 on this particular shelf. And again, there are 60 selectors, and they're all banjo wired together level-wise for my Eas routes, but yet one particular level is then wired again to another set of 60 switches, so I can continue to have my 60 continuous phone calls in the office, which would never happen in this case, but it can be done. I've dialed a 3, so on this particular switch, the office code is 377, so I'm going to dial a 7, and it is going to digit absorb. I will dial another 7, and it will absorb again, and it will continuously absorb the digit 7 for the rest of your life if that was the only digit you dialed. The thousands group I'm using in this is 5, so you got 3, 7, 7, 5. When I dial 5, it will then connect me into the 5th selector, which is in another switch frame over, and that is then where I would dial my hundreds group to get into the connector shelf. So I'm going to dial 5, and I am now sitting in another shelf, the first switch on the next shelf over, and so we've dialed a 3, a 7, 7, 5, and we will now be into the next switch frame. Alright, we've dialed 3775, and I would be sitting on this switch, so now I have a choice of which connector shelf I would like to go into. I'm going to go into shelf 5, so I'm going to be effectively dialing 37755, and then I'm going to call a phone that's directly behind me, and I'm going to dial a 7 and a 5, and the last 2 digits are being completed in a connector switch, and the phone just rang. So we have completed 7 digits through the central office. And once the person is done, they'll hang up. Now for each telephone call, as long as the call is up and in progress, the switch will be held up the entire duration. So in today's world, if you had internet traffic, this office would be at its knees, because with dial-up, every link would be held up busy for hours and hours and hours, and it was never designed or intended for that type of telephone traffic. Well, we started out as our first selectors, so I have 60 first selectors in this switch frame. Over here I have 5 selector shelves for my Eas routes to the crossbar, switch, the XY, the iTech, and the automatic electric. Up at the very top of this particular switch frame is a connector shelf. It's the 5100 group, so if you dialed 37751, you would reach a connector at the top of this switch frame. Then in this particular switch frame, again, we have 60 more links, which are the 4th selectors. Over here I have more of my Eas selectors, incoming selectors, toll completing or CNET completing, as well as selectors that will be used for the 3CL switchboard when I get that functional. And again, I have a connector shelf on the top of this bay, which is the 5200 group. And then we have the fifth selectors, which is 60 of them here. And then these are connectors, which are 200 point equivalent to a 31805 4-party or 8-party line connector. You got 200 numbers in one can and one bank, so this is used in a very tiny CDO would have had very limited traffic. And then these shelves here are going to be part of an incoming for the operators or a toll completing. I haven't got them wired up yet. And again, in the top of this shelf or bay, we have connector shelf 5500. So we can go off hook and dial 3, 7, 7, 5, 5, 7, 5, and the phone will be busy because that's the number I just dialed. Alright, the next most important thing next to the 48 volt power supply was the ringing and tone plant. When you call somebody, we have to be able to ring the telephone, of course, and that is done with 105 volt AC 20 cycle superimposed ringing. Also, in conjunction in this, you have a dial tone machine that provides actual dial tone. So when you go off hook, you hear obviously dial tone. Well, they take the same tone in a step-by-step office and send it through an interrupter to give you 120 IPM fast busy tone, which would be called an all circuits busy tone, or a slow busy tone, which is telling you that the line you called is, of course, in use. So they take a continuous tone and they interrupt it depending on what we want. Now we also have, because your phone doesn't ring continuously, you have a ring period, a silent period, and a ring period. That is being done by the interrupter as well. So we have our one ring, a long and a short, and a long, short, long, and so forth. So we have different cams to give different types of ringing. And the ringing sequence on a multi-party line is cross-connected at the mainframe, which we showed you earlier, to associate the ringing code with the number you dialed. And that is done through ground pulses, and it's a separate lead. So in this particular office, we have an actual 806, and I believe this is a Model F ringing plant. And it runs 24 hours a day, 7 days a week. And we gave you a dial tone, hopefully the sound where you can hear it. If not, we'll go to a speakerphone and we'll let you hear dial tone, busy tone later on in the office. Alright, in this particular exchange I have a group of O carrier. This is the OA group. You have 4 channels, so we can have 4 simultaneous phone calls running on a 2-conductor open wire lead. You could take multiple O systems with the correct filters and network arrangements and tie them together and have on an open wire bidirectional transmission on 2 conductors. This is all vacuum tube technology that has been changed out to field effect transistors so that it requires less power to operate. This is not yet operational, and I hope within the next couple of years to have it up and going. Alright, well, in central offices, of course, the communities will have payphones located throughout the community. In this office, I have a small line group for my payphones, and I have 21 telephones that can be concentrated down to 5 links, which would have 5 first selectors of the coin phones. Wired between the line finder and the first selector is a coin trunk. In this particular case, these are prepaid coin trunks, which means you pick up the handset at the payphone and you have to deposit a coin in order to get dial tones, the ground start line. Well, this here is the physical trunk assembly here is these 3 relay plates is what would control that. So if you dial, once you put a coin in, you get dial tone, you dial a number. If it's busy, when you hang up, you get your coin back. If it's answered, then of course we collect it. Well, this is the piece of equipment that would do the collect and return feature on a prepaid type service. Well, in the bay next to the coin trunks and so forth, I just have alarm equipment, fuse alarm, release alarm, permanent signal alarm, and trunk finders, various switchboard control functions. In the next bay, I have some inter-toll, which is to incoming and outgoing trunks between the switchboard and the step-by-step office. I have incoming E&M non-pulse correcting trunks, and none of this is currently wired. In the next bay over, I have e-signaling units. The e-signaling unit works in conjunction with the O carrier, because you have 16 channels working on one pair of wires. Well, each channel has to use SF signaling, and so I have all the SF equipment in order to do that. This converts a DC into an AC circuit, so 2600 transmit and receive, and if the channel is idle, it's sending 2600 and receiving 2600 simultaneously, and whoever goes off hook first then of course will signal the other end, and in the case of dial pulse, you're turning the 2600 cycles on, off for each pulse that you're sending out, and once it's answered, they take the 2600 off the other side so that they know that the circuit's answered. Then I have in here just various test trunks and more Untitled facilities. The next bay over, I have 60 and 120 IPM distribution for ground pulses for various equipment in the office. I have central office alarm panels, so if I have a fuse low, I'll get an indication of it. If I have a switch held up after a predetermined amount of time, I get an indication of it. And then I just have more test equipment, selector, intercept, connector, intercept, tone generators. In the next bay, we have rotary out trunk switches, which are not currently wired up, but this is kind of like a concentrator, so you can have lots and lots of selector levels down to a very limited amount of trunks, such as operator or 1+. And this is an in-between piece of equipment, so you have to dial something in order to get to a trunk that this would be associated with. We have a no such number tone generator, as well as ringer test DC key set for the test board, and other various types of test equipment. The very last bay, I have incoming and outgoing E&M trunks, two-way composite trunks, and interface trunks to my 3CL switchboard. And then, of course, over on this aisle, we have back to our line groups. So in this particular exchange, there's 5 aisles, 18 foot long, of just step-by-step and trunk equipment. We're showing you right now a picture of an outpulser. I have 2 of them in the A&ID, so whenever you make a long-distance telephone call, if you're on a private line, they can identify the number you're calling from when you make a 1+ call. Well, that is done in more of the equipment that you can't see at this moment, but this is the outpulser up here. Once it has determined your phone number, this is what sends out to the world. So you dial 1 and you reach a camera trunk. You dial your 7 or 10 digit destination number. At the end of the last digit, the toll office would then request the ANI, which is your telephone number that the call is originating from. So I'm going to make a call to a machine that's going to read back the phone number that I'm calling from.
Three, 7, 7, 5, 5, 5, 5. 3, 7, 7, 5, 5, 5, 5.
All right, you've seen the outpulser, which outpulses the digits of the number that the call originated from. Well, in order to make this work, that's one piece of an overall system. Each bay in this particular office right here, 9-foot tall bay, has 10 ANI trunks in it. I have approximately 40 of them in the office. This stuff is actually working, and it's connected to an asterisk system, then connected to CNET. So I can make a long-distance telephone call to another phone in the world, either the regular Pstn or a CNET. So I'm going to make a 1+ call, and I'm going to call myself long distance, and you'll be able to hear the call coming back into the office on an incoming selector. And I would call a number that will ring, so you'll be able to hear dial tone, the digits dialed, the call being outpulsed, the ANI being outpulsed, and then the call coming back in. So I'm going to let you hear dial tone. I'm currently calling the central office number long distance, so we're outposting and dial post right now to the asterisk system. And calls coming back into the office. And the line is busy because I called myself. So this is what a slow, busy sounds like. Now the line will be ringing, which I'm calling myself long distance through my own network. The call never left the building, but it could if I dialed a real world telephone number. Right now I've got 120 IPM busy. And I can also dial one other code. This is the asterisk system. We'll be reading back the number that I'm originating a call from.
The current time is 9:07 p.m.
Error on my part, that was the time of day. This will get us the number back.
Three, 7, 7, 5, 5, 5, 5.
Just record 2 seconds of it. Okay, we're now looking at the Stromberg Carlson XY step-by-step.